Have you ever pondered over what the most common type of star in our galaxy is? Today, we delve into the fascinating world of red dwarfs. These celestial bodies, often overlooked, are the most prevalent stars in the cosmos, holding mysteries and potential that could change our understanding of the universe. Red dwarfs are small, cool stars with an incredibly long lifespan, and they may even host habitable planets. Join us as we count down 10 captivating insights from studying red dwarfs. Beginning with Insight 10, red dwarfs aren't just common, they're everywhere. They're the silent majority, the unsung heroes of our galaxy, and they're responsible for the cosmic glitter we see when we gaze at the night sky. You see, red dwarfs make up a staggering 70% of the stars in the Milky Way. That's right, 7 out of every 10 stars you can't see are red dwarfs. Now, you might be wondering why you can't see them if they're so common. Well, they're a bit shy. Red dwarfs are smaller and cooler than our sun, which means they don't shine as brightly. But don't let their modesty fool you. They're incredibly important and have a lot to teach us. Their prevalence makes them prime targets for studying stellar and planetary evolution. Each one is a potential laboratory, a chance to learn more about the universe we inhabit. Imagine the untold mysteries they might hold, the cosmic secrets waiting to be unearthed. So, when you next find yourself under the night sky, remember this. The stars you can't see outnumber the ones you can. And each one of them, every single red dwarf, is a silent testament to the vastness and diversity of our galaxy. So next time you look up at the night sky, remember, most stars you see are red dwarfs. Moving on to Insight 9, these dwarfs are near immortal from a human perspective. Red dwarfs have an almost unthinkable lifespan stretching into the trillions of years. Let's put that into perspective. Our own sun, a yellow dwarf, has a lifespan of about 10 billion years, and it's already halfway through. Now imagine a star that could outlive the entire age of the universe, which is around 13.8 billion years. That's a red dwarf for you. Their extreme longevity is due to their slow-burning nature. Unlike more massive stars that burn through their nuclear fuel at a breakneck pace, red dwarfs are economical. They undergo a process known as fully convective energy transport. This means they mix their fuel, hydrogen, throughout their structure instead of just burning it at the core. This allows them to utilize almost all of their hydrogen before they exhaust their fuel supply. In the grand scheme of things, this makes red dwarfs the old-timers of the cosmos. They've been around since the early days of the universe and will continue to exist long after other stars have burned out. They're like the tortoises of the stellar race, slow and steady, outliving the hares by a wide margin. Their longevity also opens up exciting possibilities for the existence of ancient civilizations around red dwarf planets. If life does exist there, it would have had a lot more time to evolve and develop. In the cosmic timescale, these stars are truly ancient. For Insight 8, we learn that red dwarfs are the quiet observers of the universe. These celestial bodies, although smaller and less radiant than our own sun, have intriguing characteristics that make them no less fascinating. Unlike their larger, more flamboyant counterparts, red dwarfs are relatively cool stars. Their surface temperatures are comparatively low, ranging from about 3,000 to 4,000 Kelvin. In contrast, our sun blazes at a scorching 5,700 Kelvin. This cooler temperature results in a red dwarf's signature red hue, and their lower energy output makes them less visible in the night sky. Their cooler nature also means they emit less radiation. This is quite significant as radiation can play a significant role in shaping planetary atmospheres and possibly the potential for life. A less radioactive environment might even be conducive to life as we know it. Despite their subdued nature, red dwarfs are far from being dull. They're like the introverts of the stellar community, quietly going about their long lives, not drawing attention to themselves, yet possibly harboring planets within their habitable zones. And while we've made great strides in understanding these stars, there's still much to learn. For instance, how does a red dwarf's cooler temperature and lower radiation levels influence the planets orbiting it? What are the implications for life? These are questions that scientists are actively investigating. These silent sentinels may hold more secrets than we can imagine. Let's continue to explore the mysteries of these quiet dwarfs as we move on to our next insight. Insight 7 brings us to the captivating world of exoplanets orbiting red dwarfs. These stellar underdogs, despite their small size and cool temperature, might just be the cradles of alien life we've been searching for. The possibility of red dwarfs hosting habitable planets is intriguing. Given their abundance in the universe, it's statistically probable that a significant number of these dim stars have planets in their habitable zones where conditions might be just right for liquid water to exist. However, life in a red dwarf system would be unlike anything we know on Earth. These stars are known for their variability, often undergoing dramatic changes in brightness. This could result in a tug-of-war scenario for life on a nearby planet, with conditions fluctuating between too hot and too cold. Moreover, red dwarfs are notorious for their stellar tantrums, frequently unleashing powerful flares that could strip a planet of its atmosphere. Yet, despite these challenges, recent studies suggest that a planet's magnetic field could shield it from a red dwarf's wrath. It's a tantalizing prospect, isn't it? A whole new type of world bathed in the crimson light of a red dwarf, teetering on the edge of habitability. These planets might not be the Earth twins we initially set out to find, but they represent a fascinating new frontier in our quest to understand the universe and our place within it. The search for life in the universe might well be focused on these red dwarf systems. After all, in the grand cosmic theater, even the smallest actors can play the most captivating roles. With Insight 6, we reveal that red dwarfs are not always as quiet as they seem. It's easy to think of these celestial bodies as reserved elders of the cosmos, but in their youth, they are anything but. Just like any other star, red dwarfs go through a lively and active phase early in their lives. This vivacious period is marked by high activity and dramatic flares, akin to solar fireworks. These spectacular eruptions of energy are not just for show. They play a crucial role in shaping the red dwarf's environment and can have a powerful influence on the atmospheres of any surrounding exoplanets. Imagine a world orbiting a red dwarf during this stage. The frequent and intense flares could cause dramatic atmospheric changes, and the effects could be both devastating and spectacular. On one hand, these flares might strip away an exoplanet's atmosphere, leaving it barren and inhospitable. On the other hand, they could also trigger complex chemical reactions that might lead to the creation of new molecules, perhaps even those necessary for life. It's a cosmic dance of creation and destruction, with red dwarf stars leading the waltz. So while we often think of red dwarfs as placid celestial bodies, remember they too had a fiery youth. These fiery youngsters can have a profound impact on their planetary offspring. For Insight 5, we delve into the dim world of red dwarfs. When we think of stars, we often picture a blazing ball of fire, emitting a light so bright it reaches us across the vast expanse of space. But red dwarfs? They're a different breed altogether. Despite being the most populous stars in our galaxy, they are notoriously hard to spot. Why, you might ask? The answer lies in their luminosity. Luminosity is the total amount of energy a star emits per unit of time. It's like the wattage of a light bulb. The higher the wattage, the brighter the light. Our Sun, a G-type star, is quite the high-watt bulb in the galactic scheme of things. Red dwarfs, however, are more akin to a dim nightlight. Their low luminosity means they emit less light and heat. This has fascinating implications for the planets in their orbit. Imagine a world where daylight is more like our twilight, where photosynthesis might operate differently, where life, as we know it, might have to adapt in unusual ways to survive. But do not mistake their dimness for insignificance. Their low luminosity gives them an extraordinary lifespan extending into trillions of years. It also reduces the chances of them going supernova, providing a stable environment for potential life-bearing planets. In the case of red dwarfs, less is indeed more. With Insight 4, size does matter, especially when you're a star. In the grand cosmic theater, red dwarfs might seem like the underdogs, being the smallest in the stellar family. They're typically just 1/5 to 1/2 the diameter of our own Sun. But don't let their diminutive stature fool you. These celestial bodies are powerhouses, brimming with fascinating attributes and secrets to unravel. Their small size plays a significant role in their life story. The lesser the size, the slower the nuclear fusion process in their core. This slow-paced fusion allows red dwarfs to burn their fuel efficiently, enabling them to have lifetimes that can stretch into the trillions of years. That's right, trillions. That's far longer than our universe's current age, which is a mere 13.8 billion years. Moreover, the small size of red dwarfs also has implications for their potential planetary systems. In fact, the habitable zone, the region where conditions might be just right for life as we know it, is much closer to these stars. This proximity could lead to intriguing phenomena like tidal locking, where one side of a planet is perpetually facing its star. But it's not just the size of these red dwarfs that makes them remarkable, it's what they represent. They're a testament to the universe's capacity for diversity, for longevity, and for potential habitats beyond our own solar system. With red dwarfs, we learn that great things indeed come in small packages. Insight 3 reveals the surprising influence of these seemingly insignificant stars. Despite their modest size, red dwarfs play a significant role in shaping our galaxy. They account for a substantial portion of the galaxy's mass. Imagine that. These celestial underdogs, so often overlooked, are the unsung heroes holding the cosmic scales in balance. But there's more to their influence than just mass. Red dwarfs are also key players in the chemical evolution of the universe. They're like cosmic alchemists, transforming lighter elements into heavier ones within their fiery hearts. This process, known as stellar nucleosynthesis, is how all elements heavier than helium came to be. Yep, you heard it right. Without red dwarfs, the universe would be a very different place, lacking many of the elements crucial for life as we know it. Additionally, red dwarfs are slow burners, living for trillions of years. This gives them ample time to cook up and distribute a wide variety of elements across the cosmos. When a red dwarf finally meets its end, it doesn't go out with a bang. Instead, it gently disperses its enriched contents into the surrounding space, seeding future generations of stars and planets with the building blocks of life. Red dwarfs might be small, but their impact is anything but. Their influence extends far beyond their humble size, shaping the universe in ways that continue to fascinate and inspire us. As we near the end with Insight 2, we look at the future of these ancient stars. Red dwarfs, those celestial workhorses, are quite remarkable for their longevity. They have lifespans that stretch into the trillions of years, far beyond the age of our universe, which is a mere 13.8 billion years old. Now let's ponder about their future, a future that's intertwined with the fate of countless potential planets. Given their long lives, red dwarfs have ample time to nurture planets and, who knows, perhaps life. Imagine for a moment civilizations thriving under the steady, long-lasting glow of a red dwarf star. However, it's not all rosy. The early years of a red dwarf's life are marked by tumultuous flare activity that can strip away the atmosphere of surrounding planets. But as they age, they settle down, becoming more hospitable for potential life. Furthermore, as the universe ages and larger stars burn out, red dwarfs will become the dominant celestial bodies, outliving and outnumbering all other stars. In a distant future, they might be the last bastions of light and heat in an otherwise dark and cold universe. As we've seen, red dwarfs are key players in the cosmic drama. They have the potential to host life and will likely shape the future of the universe. The future might indeed be red. Finally, with Insight number 10, we explore the enduring mysteries of red dwarfs. Despite being the most common type of star in our galaxy, red dwarfs are far from being fully understood. Their secrets are as vast as the universe they inhabit, and our knowledge is continually evolving. The field of red dwarf research is vibrant and dynamic, with new discoveries and insights emerging regularly. For instance, the question of how red dwarfs form their planetary systems is a subject of ongoing debate. Theories abound, but definitive answers remain elusive. Another puzzle revolves around their longevity. Red dwarfs have lifetimes that far exceed those of larger stars, lasting trillions of years. But how do they manage to sustain nuclear fusion at such low temperatures for so long? This is another riddle that scientists are striving to solve. Then there's the question of habitability. We know that red dwarfs can host planets in their habitable zones, but what are the chances of these planets harboring life? And if life does exist there, what form might it take given the unique conditions of a red dwarf system? These are just a few of the many questions that researchers are grappling with. With each new discovery, we inch closer to unraveling these mysteries, but there's always more to learn. The mysteries of red dwarfs continue to captivate us, pushing us to explore further. Today, we've journeyed through the world of red dwarfs, learning about their ubiquity, longevity, quiet demeanor, potential to host life, and their many mysteries. Our cosmic voyage has revealed these celestial bodies as the most common stars in the galaxy, their lives stretching into trillions of years. We've seen their tranquil nature, a stark contrast to their tempestuous youth filled with intense stellar activity. We've also ventured into their planetary systems, discovering their potential to host habitable worlds, and delved into their luminosity and size, which, despite their dwarf status, is nothing short of impressive. Their influence on exoplanetary atmospheres has been a topic of intrigue, shaping our understanding of potential extraterrestrial life conditions. We've looked into their future and the mysteries that still shroud these celestial beings. As we continue to explore the universe, the humble red dwarf remains a beacon of fascination and wonder. Until next time, keep looking up. Before we conclude our journey, we'd like to remind you of the role you play in this cosmic adventure. If you've learned something new from our voyage through the universe of red dwarfs, show us some love with a like. Your feedback fuels our journey, so don't hesitate to share your thoughts, opinions, or questions in the comments section. We continue to explore the cosmos because of your curiosity and support. Remember, every subscription, every like, every share, and every comment brings us all a little closer to understanding the mysteries of our universe. So if you haven't already, hit that subscribe button and ring the bell to stay updated on our future explorations. Share this video with your friends and family because the wonders of the universe are best when shared. Keep looking up, and until next time, happy stargazing.